All right, so here's the answers to the examples in the notes. Just gonna bounce through them really quick here for you guys, just so I'm not wasting too much of your time. Basically, so if you read the first example, if a rock was determined to be around 3.9 billion years old, how much potassium 40 would be left in this sample? And what would the ratio of 40K to AR40 be? All right, so we want to compare how much potassium 40 there is to argon 40, because that's what potassium 40, when it breaks down, it's reduced to argon 40. So you look in the notes and you see that your half-life for potassium 40 is 1.3 billion years. So then you take your half-life, and what you're going to do is you'll find out how many years, how much time has gone by, and you're going to divide that by your half-life. So I went 3.9 billion divided by 1.3 billion, that's going to give me 3, and that's how many half-lives there are. So I have to go through 3 half-lives now. So after my first half-life, I'm going to have 50% potassium to 50% argon. After another half-life, I'm going to reduce half of my 50 down again, so I now have half of 50 is 25% potassium, and then 75% argon. Then I do that one more time, so I divide 25 by 2, I get 12.5, and that's going to make this 87.5, because the whole ratio has to add up to 100. So that's, so to find out how much would be left, it would be 12.5%, or it'd be a ratio, so all I do is I just take how much potassium I have there, 12.5, divide both numbers by 12.5, and my ratio becomes 1 to 7. So for every 1 atom of potassium 40 I have 7 argon 40s. All right, so now for the second example, if someone told you that the original sample of radioactive uranium-238 had a mass of 400 grams, what would the total amount of uranium-238 sample be that was left for 9 billion years? All right, so I look up the half-life of uranium-238, and it's 4.5 billion years. So I just go 9 billion divided by 4.5. That's going to give me 2 half-lives. So I know after 1 half-life, I have half the ratio, or half my original sample left. After 2 half-lives, I'm going to have half of a half, which is a quarter. So I have a quarter of my original sample of uranium-238 left. So that means my total amount is going to be 1/4 of 400. So I go 1/4 times 400, and my amount would be 100 grams. Okay? For all examples and all questions that I give you guys, you will have to look up the half-lives on the table. It would always be provided for you. I'm not expecting you guys to memorize the half-lives of different elements, okay? That's crazy. All right? So just be aware of that. All right, let's move on to some relative dating questions now. Now, when I do relative dating, what I always do is I always list the layers from oldest to youngest first. So I know that due to the principle of superpositioning, the bottoms on the layer, or the layers on the bottom, there we go, are my oldest. So C is my oldest, then E, then D, then B. Right here, C, E, D, B. I write those out first all the time. Then what I do is I have to go back and I have to look at my different events that have occurred beyond the layering. Like this one here has an intrusion of magma. Sometimes you'll have faults or unconformities, anything like that that could happen. So then you got to account for those and put those in accordingly. So I know that by looking at this, A definitely happened after layers C, E, and D were laid. Okay, I can see that because it jutted through them. So, and then spilled out on top of B, or on top of D, and then layer B was layered on top. So I know that layer, or event A, happened in between D and B right here. So if I rank these, it goes C, E, D, A, then B. Okay? Now for this one here, carry out and do the same thing again. You layer you You rank your layers, oldest from youngest, from whatever's on the bottom to what's up on top. Okay. All right, so now we need to determine where B and E occurred. I'm going to start with B because it looks like B only affected the bottom part of my drawing here. So I'm going to say because it's closer to the bottom, more affected, that it's older. So I know B comes before E for sure. So where does it occur? If I look here, B definitely pushed everything up, right? It brought all of this up. So we know B pushed everything up, and if we look here, we have this unconformity, all right? And it also comes in over here, I can see it. And it looks like what it did is it eroded everything away here. And it looks like there was this layer F as well, but because everything was pushed up, F here was eroded away and H was laid down on top of it. So I would say that B is younger than F, but older than H. Okay? If this would have been pushed up and let's say there would have been a layer of F up here, then I would have known that H is definitely older than F. But because F is in between and only in this area here, then you could tell that it's definitely younger than B, or younger than H. Oh, too far. All right, so now I need to figure out where E goes. E is definitely a break that pushed this layer back down. Okay, it happened after B for sure because we can see that there's no E over here. But the trick is to figure out when it occurred. Now, based on this drawing, you could really come up with two answers. It either happened before I, and you can't tell because maybe there's a layer of I up here, or this happened afterwards, or it happened after I was laid down. Because we don't know what's above D here, we really can't say. So it's either or. It's just inconclusive based on the data. Right, we're just dealing with a single little snapshot here. It's hard to tell. If there was more information provided, like if we were actually out there looking at this, say it was the Grand Canyon or something, it's easier to put that picture together. But when we're only doing an activity like this, it gets a little more difficult. All right, now for this guy, I started with only the layers. I didn't put this magma in here, okay, just because of how it juts out. This was probably a buildup and then it spewed out over here. So I said layer D, H were my oldest two, then A after that. And then I said, I put my layers F, I, B, E in here as well, F, I, B, E. But then I had to determine when this fault here occurred and when C occurred. Now if you look, the magma shoots out and you can even see a little bit over here. Right? It matches this here. So it definitely, this C occurred before G. But if you look, there is no magma here in layer F, I, or B. So you could see that F was laid down after the magma for sure. So we know that F goes before C over here. So then it just leaves me with G. And I can see that G, well, you can't really see it with all my drawings on there. This fault occurred after the magma was spewed out. So G is definitely younger than C. So then I rank them oldest to youngest, and I would say it's D, H, A, C, G, F, I, B, E. Okay, so those are the examples. Make sure you try the practice worksheet before you do the hand-in worksheet as well. And let me know if you have any questions.